Look, Professor, I think we've finally reached the village of limits.
Yes, Luke, we're finally here. The curious village of limits. Let us see if there's anything interesting.
Professor, the bridge to the village is broken. What shall we do?
Very well, Luke. I'm sure that there will be a solution to the problem. I think the villagers are trying to see if we are capable of cracking the mystery of the limits. You care to give it a go?
Yes, sir. I will do my best.
Very well then, Luke. Let us proceed.
Welcome to the Bridge of Continuity. Unfortunately, you cannot enter our village of limits unless you solve our problems correctly. Good luck. All of the functions are continuous except a. f of x equals k, b. f of x equals x, c. f of x equals x squared, d. f of x equals the greatest integer function of x.
The answer is D, the greatest integer function of x.
Correct, the bridge connects. Basically, a continuous function means that there is no break in the function. If f of x is defined in an open interval containing x equals c, then f is continuous at x equals c if limit f of x as x approaches c equals f of c. If the limit does not exist, or if it exists but is not equal to f of c, then we say that f of x has a discontinuity at x equals c. Keep in mind that there are three conditions for f of x to be continuous. Number 1, limit f of x as x approaches c exists. 2, f of c exists. 3, they are equal. In addition, there are three general types of discontinuity: removable discontinuity, jump discontinuity, and infinite discontinuity. Removable discontinuity is considered mild and can be made continuous by redefining f of c. A worse type of discontinuity is jump discontinuity, which occurs when limit f of x as x approaches c from the left and limit f of x as x approaches c from the right are not equal. A jump discontinuity cannot be made continuous. Infinite discontinuity occurs when one or both sides of the limits is infinite. Professor, we succeeded in fixing the bridge. We are now really inside the village of limits.
Yes, Luke, but do not be too excited yet. I'm sure that there will be more problems for us to answer in this village.
Hello, welcome to the village of limits. You two have successfully entered our village, but you still have a long way to go. In order to proceed, you need to answer my questions correctly.
Okay, what is the question?
See if you can answer this one.
Identify the type of discontinuity and determine the points at which the function is discontinuous.
This function has a jump discontinuity at x equals 2.
Correct. Here, the function is discontinuous at x equals 2, and the function is a jump discontinuity. We know this because limit f of x approaches 5 when x approaches 2 from the right, but limit f of x approaches 3 when x approaches 2 from the left.
Congratulations! You may now proceed to our main gate.
Professor, we're now at the main gate. I cannot wait to see things inside the village.
Me too, Luke. There, I think I see a gatekeeper in the front. He might be another person to ask us a question. So beware.
Welcome to the village of limits. Congratulations on coming to the main gate. Once you answer my last question, you two are now ready to enjoy our festival inside the gate.
Yay! I cannot wait to solve our last question.
Well, here you are, the very last question of limits.
Use the laws of continuity and other theorems of continuity to show that the functions are continuous. First of all, we should know what the laws of continuity are. According to the laws of continuity, if f of x and g of x are continuous at x equals c, then the following conditions are also continuous at x equals c. F of x plus g of x, f of x minus g of x, f of x times g of x, k times f of x, where k equals constant, f of x over g of x, where g of x is not equal to 0. In the first question, the numerator x squared minus sine x consists of two functions, x squared and sine x. According to the continuity theorem of basic functions, sine x is continuous on the real line. Therefore, both functions are continuous at x equals c. and subtracting one function from the other function would also give us a continuous function. The denominator 1 plus sine x also consists of two continuous functions, so adding them together will still produce a continuous function. Since the numerator and denominator are both continuous functions by the laws of continuity, dividing the two functions still yields a continuous function. The same law can be applied to question 2, x squared plus 5 to the power of 1/3, as a composite function f of x equals f of g of x, where g is continuous at x equals c, and f is continuous at x equals g of c. The two functions in this question are x squared plus 5 and x to the power of 1/3. By the laws of continuity, x squared plus 5 is a continuous function. X to the power of 1/3 is also a continuous function because the equation in the format of y equals x to the power of 1 over n is continuous on its domain, provided that n is a natural number. Therefore, the composite of these two functions is still continuous.
Wow, Professor! We're finally inside the village! Look at the celebrations! It's amazing!
Indeed, Luke. It is amazing. I cannot wait to solve more mysteries of limits in this wonderful village.